Hello everyone, today we are going through addition of vectors. See in this figure, vector AB. Vector AB represents displacement from A to B, right? And vector BC represents displacement from B to C. Okay, now what is AC? See, what is displacement? Displacement is nothing but shortest distance between initial point and end point, right? So here it is the initial point and it is the end point. So here the total displacement is nothing but AC, that is vector AC. Vector AC is the displacement from A to C. That is nothing but, see here the total displacement. Net displacement is vector AB plus vector BC, that is equal to vector AC. Right? So it is the law of vector addition, triangle law of vector addition. So here vector AC is equal to vector AB plus vector BC. That is total displacement. Okay, we know that displacement is the shortest distance between initial point and the end point, terminal point, right? So here it is the initial point and it is the terminal point. Okay, so here it is the displacement, total displacement of, see, from A to C. Okay, vector AB plus vector BC, that is equal to vector AC. Okay, so vector AC is equal to vector AB plus vector BC. It's called triangle law of vector addition. Look at this figure. Here vector AB, vector BC and vector CA are three sides of a triangle taken in order. Okay, vector AB, vector BC, vector CA. Then what is sum of this? Vector AB plus vector BC plus vector CA. That is equal to 0. Why? Vector 0. See here. Here what is the initial point? Vector AB starting from A, right? Initial point is A. And vector BC, okay, from this vector BC, then vector CA. See, what is the end point? End point is also A. That is terminal point is also A. Therefore, this vector is nothing but vector AA. That is nothing but 0 vector, because here the distance is 0. Okay. Therefore, vector AA means initial point and terminal points both are same, right? That is called vector magnitude is 0. We know that what is a 0 vector? 0 vector is nothing but which has magnitude 0 is called 0 vector, right? So here vector AA, here initial point and terminal points are same, that is there is no distance, distance is 0, right? Therefore that is magnitude is 0. Therefore it is 0 vector. So remember vector AB, vector BC and vector CA are three sides of a triangle taken in order. Okay. Then vector AB plus vector BC plus vector CA is equal to 0. Look at this figure. Here it's a parallelogram and it is vector A, vector B, vector A, vector B. So here by triangle law of addition, it is nothing but vector A plus vector B. That is vector A plus vector B, that is equal to, here it is the resultant vector, that is sum of this vector, that is vector A plus vector B. Okay, by triangle law of addition, vector addition. And here, so here we can write vector OA, that is vector OA plus vector AB, vector AB, that is equal to vector OB, right? Vector OA plus vector AB, that is equal to vector OB by triangle law of vector addition. Okay, and see here, see it's a parallelogram, right? So all the sides are equal, right? That means here magnitude of all these vectors are same, right? And what is that? What about direction? See here vector B we can say this vector, that is vector OC is equal to vector AB, right? Because magnitude and direction both are same, right? Therefore, vector OC is equal to vector AB. Vector OC is equal to vector AB, right? So here let's apply this one in this equation. That is, we get vector OA plus vector AB is equal to vector OC, right? So vector OC, that is equal to vector OB. Okay, that means this vector plus this vector is equal to this vector, that is diagonal. Okay, so it is called parallelogram law of vector addition. Okay, is called parallelogram law of vector addition. Okay, that is vector OA plus vector OC. Okay, vector OA plus vector OC, that is equal to vector OB. Okay, vector OA plus vector OC, that is equal to vector OB. Now we are going through properties of vector addition. First one is commutative property. Here we have to show vector addition is commutative. That is, for any two vectors, vector A and vector B, vector A plus vector B is equal to vector B plus vector A. See here. Here by triangle law of vector addition, we know that vector OA plus vector AB, that is equal to vector OB. Right? That is vector A plus vector B is equal to vector A plus vector B. Okay. So this diagonal is vector A plus vector B. Okay. Again, look at this upper triangle. Here also we will apply triangle law of vector addition. See here also vector OC plus vector CB, that is equal to vector OB. Right? That is vector B plus vector A is equal to this diagonal vector OB. Okay, this vector OB. So here we have got vector OB is equal to vector A plus vector B, and vector OB is equal to vector vector A plus vector B, right? And vector OB is equal to vector B plus vector A. That implies vector A plus vector B is equal to vector B plus vector A. Therefore, vector addition is commutative. Next is second one, associative property. Very important. So here we have to prove this vector addition is associative. That is, for if vector A, vector B and vector C be any three vectors, then vector A plus vector B plus vector C, that is equal to vector A plus vector B plus vector C. Okay, this one we have to prove. Okay, so here for that, let vector OA, that is equal to vector A. Okay, vector OA is equal to vector A, and vector AB is equal to vector B, because we have to prove in this, right? Therefore, we named it as vector OA is equal to vector A, and vector AB is equal to vector B, and vector BC is equal to vector C. Okay, then. So first of all, let's consider LHS. That is vector A plus vector B plus vector C, that is equal to. What is vector A? Vector A is vector OA, right? Plus inside the bracket vector B. What is vector B? Here we have given vector AB. Vector AB is equal to vector B, right? That is vector AB plus C. What is vector C? Vector BC. Vector BC. Right? Okay. So what is vector AB plus vector BC? Vector AB, vector BC, that is equal to vector AC. Isn't it? By triangle law of vector addition. Right? That is vector AB plus vector BC, that is equal to vector AC. So here this can be written as vector OA plus, it is nothing but vector AC. Vector AC. Okay. Now we have got vector OA plus vector AC. Vector OA plus vector AC, that is equal to, again by the triangle law of vector addition, vector OC. Right? Vector OA plus vector AC, that is equal to vector OC. Okay? That is equal to vector OC. Okay. So what is vector OC? Okay. Vector OC, leave it here. Next, let's consider RHS. Okay. That is vector A plus vector B plus vector C. Okay. Inside the bracket, vector A, that is vector OA plus vector B, vector AB plus vector C is vector BC. Okay. Then that is equal to, here what is vector OA plus vector AB? Vector OA plus vector AB, that is equal to vector OB by the triangle law of vector addition. Okay. Vector OA plus vector AB, that is equal to vector OB. That is vector OB plus vector BC. Okay. Now what is vector OB plus vector BC? Vector OB plus vector BC, that is equal to vector OC. Right? Here we have applied only triangle law of vector addition. Okay. Here vector OB plus vector BC, that is equal to vector OC. Right? That is equal to vector OC. See, we have got LHS is equal to vector OC and RHS is also vector OC. That means vector A plus, that is LHS, is equal to RHS. Vector A plus vector B plus vector C, that is equal to vector A plus vector B plus vector C. Okay. Therefore, vector A plus vector B plus vector C is equal to vector A plus vector B plus vector C. Therefore, vector addition is associative. Now we are going through multiplication of a vector by a scalar. That is scalar multiplication of a vector. So for that, let vector A be a vector and lambda be a scalar, that is any real number. Then product of scalar and the vector A, is a vector and it is denoted by lambda into vector A. Okay, that is product of a scalar and the vector is a vector and it is denoted by lambda into vector A. And its magnitude is modulus lambda into vector A, that is equal to modulus lambda into modulus vector A, that is magnitude of vector A. So lambda into modulus lambda into magnitude of vector A. Okay. See, for example, here vector AB, that is equal to vector A, and vector CD, that is equal to vector 2A. So this can be written as vector CD, that is equal to 2 into vector AB, right? Vector CD is 2 into vector A is vector AB. Okay. Then what is its magnitude? That is modulus of vector CD is equal to modulus of 2 into modulus of vector AB. Modulus of 2 is nothing but 2 itself, right? So 2 into modulus of vector AB. Okay. Now here let's take, see here AB and CD have same direction, right? So next let's take, they have opposite direction. What if they have opposite direction? Here it is minus 2A. If it is opposite, it is minus 2A. Okay. Therefore here we can write vector CD is equal to minus 2 into vector AB. Okay. Here lambda is minus 2. Vector CD is equal to minus 2 vector AB. And what is its magnitude? That is modulus of vector CD is equal to modulus of minus 2 into modulus of vector AB. Okay, that is minus 2, modulus of minus 2 is 2. 2 into vector AB, modulus of vector A. See, we have got the same magnitude, right? So, if it is in the opposite direction, its magnitudes are same. Okay, their magnitude are same. So, here vector A, let's take EF. It is opposite direction, vector minus A. Minus vector A. So here also vector A and minus vector A, they have same magnitude but opposite direction. Okay, so remember vector A and minus vector A have the same magnitude but opposite direction. Next is unit vector in the direction of non-zero vector, vector A. Here we will learn method to find the unit vector in the same direction of a non-zero vector. Okay. So here we have taken vector A. Okay. So vector A be a non-zero vector. Okay. Vector A be a non-zero vector. Since it is a non-zero vector, what is its magnitude? Not equal to 0, right? That is magnitude of vector A, that is not equal to 0. Okay. If magnitude is 0 means the vector is not a 0 vector, right? Here we have taken vector A is a non-zero vector. Okay. Then let lambda is equal to 1 by modulus vector A. Okay. We have taken lambda that is equal to 1 by modulus vector A. So here it is clear that lambda is positive. Right, modulus of vector A, that will be positive, right? Magnitude of a vector. Here, positive. Therefore, lambda is positive. Okay, lambda is positive. And what is magnitude of? That is magnitude of lambda into vector A. That is modulus of lambda into vector A. That is modulus of lambda into vector A can be written as modulus lambda into modulus vector A. Right? That is, what is modulus of lambda? That is 1 by modulus of vector A into modulus of vector A. Right? Modulus of lambda into vector A, that is lambda into vector A, scalar multiplication of vector, that is a scalar, lambda is a scalar and vector A is any vector. Okay. So here that it's also a vector, right? Lambda into vector A is a vector and its magnitude, that is modulus of lambda into vector A, that is equal to this one, that is 1. Okay. See, here we have got magnitude of lambda into vector A, that is equal to 1. What does it mean? Here we studied that a vector which has magnitude 1 is called a unit vector. Right? That means here lambda into vector A is a unit vector. It implies lambda into vector A is a unit vector. Okay? And here the direction of, since this lambda is positive, right? Lambda is positive. Therefore, here the direction of lambda into vector A is same as that of vector A. Right? Because lambda is positive. Okay? Therefore, direction of lambda into vector A is same as that of vector A. Okay. Now we can write the unit vector in the direction of vector A is, how to denote? A cap. Unit vector denoted by A cap. Okay, read as A cap. A cap is equal to, what is our unit vector? Lambda into vector A. Right? That is lambda into vector A. What is lambda? Lambda is 1 by modulus of vector A into vector A. Okay. Therefore, unit vector A, that is unit vector in the direction of vector A, that is A cap, is equal to 1 by modulus vector A into vector A. It's very important. So you should understand the concept. Here unit vector in the same direction, okay, same direction of vector A, that is equal to, that is A cap is equal to 1 by modulus vector A into vector A. That's all. Now we are going through components of a vector. See, we have three-dimensional plane, XYZ plane. Here let's take 3 points. On x-axis, a point on x-axis A of 1, 0, 0. Okay, that means this distance is 1. Okay, a point on the x-axis, here y and z coordinates are 0. Right? And let's take a point on y-axis, that is B of 0, 1, 0. That is y coordinate is 1 and x and z coordinates are 0. Okay. Next, let's take a point on on z axis, C 0, 0, 1. Here this distance is 1. Okay. Now here it is the center O. Then what is vector modulus of vector OA? See, here we know that this distance is 1, right? Therefore, the vector OA, magnitude of vector OA is nothing but 1, right? That is, modulus of vector OA is equal to 1, and here modulus of vector OB is equal to 1 and modulus of vector OC is equal to 1, right? That is, what does it mean? See, these magnitudes of these vectors are 1. That means, see, we know that a vector which has magnitude 1 is called a unit vector, right? Therefore, vector OA and vector OB, vector OC are unit vectors, and here we can see vector OA is along y-axis and vector OB along the vector OA is along the x-axis, vector OB along y-axis, vector OC along z-axis, right? That is, vector OA, vector OB and vector OC along are unit vectors, along the direction of x-axis, y-axis and z-axis respectively, right? Okay, that is vector OA, vector OB and vector OC are unit vectors along in the direction of x-axis, y-axis and z-axis respectively. And let's denote these unit vectors x-axis by I, that is vector OA is equal to I, and y-axis by J and z-axis by K. That is, vector OA is equal to I cap. Since these are unit vectors, we denote it as cap. Okay, I cap. Vector I, that is I cap. Vector OB is equal to J cap and vector OC is equal to K cap. Okay, therefore it is the vector I, it is vector J and it is vector K. Okay. Now let's take a point on the plane P. Okay, let P of XYZ be a point on the plane. And here, see, here we know that how to plot the points in three coordinates, that is three-dimensional plane. Okay, so here, see, it is XYZ, right? So here, let's take a point, that is, this distance is X. Okay, this distance is X. Therefore, it is, let's take, it is Q, okay, Q, and from this here, that is, see, this distance is Y, it is R, okay, because X, Y, Z, so it is X, it is Y, and this length is Z, okay, it is X, Y, and Z. Okay, Now here this distance is xyz. Now what is the vector OQ? See here vector OQ is nothing but it is the product of unit vector and the scalar. Okay, what is the scalar here? X, right? That is this distance. Okay, so vector OQ is equal to, here vector OQ is equal to xi. Okay, xi cap. And vector QR. Vector QR is equal to yj cap. Okay, that is, see y is nothing but this distance, that is on the along the y axis, right? So it is the distance QR, the distance is y, but vector QR is product of unit vector along the same axis and the scalar, that is yj cap. And here next is RP. So vector RP is equal to j k cap. Okay, that is vector OQ. Vector OQ is equal to xi. Therefore, this vector is xi and this vector is yj cap and this vector is zk cap. Okay, vector RP is zk cap. Okay, then here by the triangle law of vector addition, here we can write vector OQ plus vector OR, that is equal to vector OR. That is vector OQ plus vector QR, that is equal to vector OR, right? So here we can write okay, we have got vector OQ is equal to xi, vector OR is equal to yj and vector RP is equal to zk, right? So here by triangle law of vector addition, here we can write vector OR plus vector QR, that is equal to vector OR. Okay, that is vector OQ plus vector QR is equal to vector OR, right? By triangle law of vector addition. What is vector OQ? That is xi, right? Xi plus it is QR. But what is vector QR? It is QR, not OR. Okay, QR is yj. That is equal to vector OR. Okay. Next, see what is this one? From the origin to the point, see it is position vector, vector R. Okay, position vector, vector R. So here, see vector OP. What is vector OP? Vector OP is equal to vector OR plus vector RP. Okay, vector OR plus vector RP. Vector RP, that is equal to vector OP. Same, that is by the triangle law of vector addition. Okay, so here also vector OP, that is position vector, vector OP is equal to vector OR plus vector RP. Okay, now that is equal to, see what is vector OR? Here we have got, right, vector OR is equal to xi plus yj. Xi plus yj. And what is vector RP? Vector RP is nothing but zk plus zk. What is vector OP? That is a position vector, vector R. Right? See here we have got vector R is equal to xi plus yj plus zk. When P is a point, that is R is a position vector of the point P of xyz with respect to the origin O. Okay, that is R is a position vector of the point P of xyz with respect to the origin, that is with respect to the origin O. Okay, so then vector R is equal to xi plus yj plus zk. So what is the distance? See, what is the distance of this R? We have already found, right? that is modulus of vector r is equal to square root of x square plus y square plus z square. Okay. Now here, if vector A is equal to a1i plus b1j plus c1k, then vector B is equal to b1i plus a2i plus b2j plus c2k. Then what is the addition of these vectors? That is vector A plus vector B is equal to, here vector that is a1 plus a2 into vector I. Okay, plus I will write it here, vector A plus vector B is equal to a1 plus a2 into vector I plus b1 plus b2 into vector j plus c1 plus c2 into vector k. And subtraction, that is vector A minus vector B is equal to a1 minus a2 I plus b1 minus b2 j plus c1 minus c2 k. Now let's go through some examples. Look at the first question. Find the values of x, y and z so that vectors vector A is equal to xi plus 2j plus zk and vector B is equal to 2i plus yj plus k. Here I, j, k are unit vectors. Okay. And here see, it are equal. Okay. So it is given vector A and vector B are equal. So remember, if two vectors are equal if and only if their corresponding components are equal. Okay, that is vector A is equal to vector B implies xi plus 2j plus zk is equal to 2i plus yj plus k. Okay, so remember, two vectors are equal if and only if their corresponding components are equal. Okay. Therefore, here x is equal to 2. That implies x is equal to 2 and y is equal to 2. Right? Y is equal to 2 and z is equal to 1. Okay. So, the values of x, y, z are 2 to 1 respectively. Second question is, find a unit vector in the direction of the vector A is equal to 2i plus 3j plus k. How to find the unit vector? We know that unit vector in the direction of vector A is equal to, that is unit vector A is equal to 1 by modulus of vector A into vector A. That is, here we have to find modulus of vector A, that is magnitude of vector A. So here modulus of vector A is equal to, how to find the magnitude? That is root of 2 square plus 3 square plus 1 square. Okay, because we know that if r is equal to xi plus yj plus zk, then modulus of vector r is equal to square root of x square plus y square plus z square. Right? So similarly, here modulus of vector A, that is magnitude of vector A, is equal to square root of 2 square plus 3 square plus 1 square. Okay, that is equal to 4 plus 9, here 10, 14, right? Square root of 14. Okay, so here square root of 14 is the value of, that is magnitude of this vector A. And we have to find the unit vector in the direction of the vector A. That is unit vector in the direction of vector A, that is denoted as A cap. Okay, A cap is equal to 1 by root 14 into vector A, that is 2i plus 3j plus k, or we can write it as 2 divided by root 14i plus 3 divided by root 14j plus 1 by root 14k. Okay, it is the required unit vector. Find the value of x for which x into I plus j plus k is a unit vector. It is given that given vector is a unit vector, then what is the value of x? What is a unit vector? A vector which has magnitude 1 is called a unit vector, right? That is, magnitude of this given vector is 1. So, given vector is xi, x into I plus j plus k, that is xi plus xj plus xk, right? So, magnitude of this vector is equal to 1. Okay? So, that is modulus of xi plus xj plus xk is equal to 1. So, how to find the modulus? That is square root of x square plus x square plus x square is equal to 1. That is root 3x square is equal to 1. Square it on both sides. Square on both sides. So, it will be 3x square is equal to 1 square, 1 itself. Okay, that implies x square is equal to 1 by 3. That implies x is equal to 1 by root 3 plus or minus 1 by root 3. So, the value of x plus or minus 1 by root 3. Show that the vectors 2i minus 3j plus 4k and minus 4i plus 6j minus 8k are collinear. We know that two vectors are collinear vectors if they are parallel to the same line, right? Otherwise, see here we can say vector A and vector B. Vector A and vector B are said to be collinear vectors. Then vector A is equal to scalar multiple of vector B. That is, vector A is equal to lambda into vector B. Here lambda is any real number. Okay. If vector A is equal to lambda into vector B, then we say vector A and vector B are collinear vectors. Okay. So here, let's take vector A is equal to 2i minus 3j plus 4k. And vector B is equal to 4i plus 6j minus 8k. Okay. See here vector B, 2 is common, right? Let's take it out. So 2 into, take minus 2 outside. Okay. So minus 2 taken outside. Then inside the bracket 2i plus 3j minus 4k. That is nothing but minus 2 into, see this vector is nothing but vector A, right? So vector A. Here we have got vector B is equal to minus 2 into vector A. That is vector B is equal to scalar multiple of vector A. That means here vector A and vector B are parallel to the same line. Okay, vector A and vector B are, suppose see it is vector A, okay, and it is vector B and it is parallel to the any line M. Okay, so here vector A and vector B are parallel to the same line. Therefore, here given two vectors are collinear vectors. Let A of 1 to 4 and B of 2 minus 1 3 be 2 points. Find vector AB. Find a unit vector along vector AB. See, very important question. Here we have a three-dimensional plane, x, y, z plane. A and B are any 2 points. Okay. So let's take here a vector, that is point A of 1, 2, 4 and point B of here any points. Okay. So I just plotted these points here. So B of 2 minus 1 3. Okay. Now let's join it. Okay. So here by triangle law of vector addition, we can say, see, we can write vector OB is equal to vector OA plus vector AB, right? Vector OA plus vector AB, right? That is, by triangle law of vector addition, vector OA plus vector AB is equal to vector OB, right? That is, vector OB is equal to vector OA plus vector AB. So we have to find vector AB, right? So vector AB is equal to vector OB minus vector OA, right? Taken this vector OA left side. So it will become vector AB is equal to vector OB minus vector OA. Now we have to find vector AB, right? So let's substitute. What is vector OB? It is the origin, right? So vector OB. What is the vector OB? That is, it is 2I minus j plus 3k. It is the vector OB. Okay. And what is the vector OA? That is minus I plus 2j plus 4k is the vector OA. And here it's a subtraction, that is 2 minus 1 is 1, that is I, minus 1 minus 2, that is minus 3j, okay, plus 3 minus 4, that is minus k. Okay, so it is the vector AB. Okay, vector AB is I minus 3j minus k. And here next we have to find, second question is find a unit vector along vector AB. See, we know that how to find the unit vector along in the direction of vector A. That is vector, that is A cap is equal to unit vector A is equal to 1 by modulus of vector A into vector A, right? So here we have to find the unit vector of vector AB along the vector AB, along the direction of vector AB. That is, here unit vector along the vector AB, is equal to 1 divided by modulus of vector AB into vector AB, right? That is, unit vector along vector AB is equal to 1 by modulus of vector AB into vector AB. So here we have to find modulus of vector AB. How to find modulus of vector AB? That is square root of 1 square plus minus 3 square plus minus 1 square, right? That is, modulus of vector AB is equal to modulus of I minus 3j minus k. That is equal to square root of 1 square plus minus 3 square plus minus 1 square. That is equal to 9 plus 1, 10, 11. Square root of 11. Right? So here magnitude of vector AB is square root of 11. Therefore, unit vector is equal to, unit vector along vector AB is equal to 1 by root 11 into vector I minus 3j minus k. That is 1 by root 11 I minus 3 by root 11 j minus 1 by root 11 k. So it is the required unit vector along vector AB.